Myself Sanjeev Goyal. I am working as senior lecturer at Government Polytechnic College, Bathinda. Today our topic of discussion is transducers, that is variable, resistive, capacitive and inductive type transducers. As per law of conservation of energy, energy can neither be created, it can nor be destroyed, and it can only be transformed from one form to another form. So, basic principle of transducer is that transducer is a device, usually electrical, electronic or electromechanical, that converts one type of energy to another for various purposes, including measurement or information transfer. It must produce the output which depend on some way on the input quantity or measurement. That means, the output we get depends upon the input quantity or the quantity which we want to change or which we want to transfer. Its output will depends on its input if it processes upon the actual input. So, transducer extracts some energy from the measured medium. Some energy is also required to convert input to output. This energy can be supplied from outside or from by the measurement only. So, according to the energy required, there are two types of transducers. First is active transducer and second one is passive transducers. Active transducers are those which does not require an external power supply to provide an output signal. These transducers usually rely upon magnetic inductance or piezoelectric effect to produce their output signals. That means, they does not require any external supply, external source, and they rely upon the magnetic inductance effect and or piezoelectric effect to produce output signals. Examples are piezoelectric crystal used for the measurement of acceleration. Measurement is converted into output without any form of energy requirements. These type of active transducers are also called as self-generating type transducers. Then comes passive transducers. Passive transducers need an external power supply in order to amplify the input and generate an output signal. All passive transducers change one of or a combination of the three general circuit parameters. These circuit parameters are resistance, inductance or capacitance. So, in passive transducers we require external source of supply to convert to generate an output signal, and in these transducers any one of these three circuit parameters, that is resistance, inductance or capacitance, may be changed. For example, potentiometer is used for measurement of pressure, displacement and position, and in potentiometer there is a change of resistance according to input quantity. So, in both type of transducers, that is active and passive, active transducer does not require any external supply. Their basic principle depends upon magnetic effect as well as piezoelectric effect, whereas in case of passive transducers they need an external source of supply to convert input into output, and they change one of the circuit parameters, that is resistance, capacitance or inductance. Examples are potentiometer in case of passive transducers and piezoelectric crystals in case of active transducers. Some of the basic requirements for a transducer are: first is linearity. Linearity of any transducer is the prime requirement. A transducer having linear input output characteristics is a big plus. Linear means the relation between input and output must be linear. Second main requirement is repeatability. A transducer having this quality produces the same result again and again when the same input signal is applied repeatedly under the same environmental conditions, for example temperature, pressure, humidity, etc. That means its output remains same for the same input under same conditions. We get repeatedly same output. Then rigidness. A transducer should be robust in construction. It should be mechanically strong, mechanically rigid, so that it is capable of withstanding overload. It does not be a delicate system. It is a mechanically strong device. Next is high signal to noise ratio. The quality of output signal of transducer should be good. In case it must be free from, it should be free from internal and external noise. It should be free from any type of interference. Highly reliable. Output of transducer should be highly reliable and stable. It should be precise. It should be up to point. It should give minimum error in measurement for temperature variations, humidity variations. The possibility of error should be minimum or negligible. Good dynamic response. A transducer may be called upon to respond to either slowly varying inputs or dynamic signals. That means its output must be same, its response must be same for slowly changing inputs or dynamic changing inputs. Its output should be faithful to input when taken as a function of time. No hysteresis. A good transducer is free from hysteresis. It should not introduce any hysteresis during measurement while input signal is varied from its low value to high value and vice versa. Hysteresis is a magnetic effect introduced in some magnetic devices. So, in case of transducers, our requirement is that it should be free from any type of hysteresis when the input changes from low to high value or high to low value. Residual deformation. There should be no deformation of testing material after the removal of any pressure after long period of time application. That means its shape should remain same. It should not deform after the removal of any type of pressure which we exert on the device for any type of calculation, any type of measurements. So, these are the some 6 or 8 some basic requirements of a transducers we get to get faithful output. So, transducers are basically of 3 types, that is variable resistance, variable capacitance and variable inductance type transducers. First of all, we are going to discuss variable resistance type transducer. The variable resistance transducers are one of the most commonly used types of transducers. The variable resistance transducers are also called as resistive transducers or resistive sensors. These type of transducers are used for measuring various physical quantities like temperature, pressure, displacement, force, vibrations, etc. Obviously, in these types of transducers, there is a variation in the value of resistance due to the input quantity, and accordingly we can measure the various physical quantities in proportion with the change in the resistance. These transducers are usually used as secondary transducers, where the output from primary mechanical transducer acts as a input for variable resistance transducers. That means variable resistance transducers are generally used as secondary type of transducers. They get input from one of the primary mechanical transducer. The output we obtained from it is calibrated against the input quantity. There is a calibration, there is a calculation of the output against input, and it directly gives the value of input. The basic principle of working of variable resistance of resistance type transducer is that the variable resistance transducer elements work on the principle that resistance of any conductor is directly proportional to the length of the conductor and inversely proportional to the cross sectional area of the conductor. Thus, for example, if L is the length of the conductor in meters, A is the area in square meters, therefore, its resistance in ohms is given by R is equal to rho, rho is a Latin word, L upon A, where L is the length, A is the cross sectional area in meter square, and rho is the resistivity of the resistive material. This resistivity rho depends upon the type of material we use, type of conductor we use. So, resistance can be changed if any of these values rho, L or A is changed. If any of these parameters, either resistivity or length of the conductor or area of the conductor is changed, its resistance can be changed. The measurand is connected to the resistance in such a way that it varies any one of its parameters. So, with the measurand, the quantity we want to measure, any one of the parameter of the conductor varies. A change in the value of resistance R is proportional to the measurand. So, there is a change in the value of R which represents the change in the value of input. Thus, the measurand can be measured by measuring the change in resistance. Rho is called as resistivity of material and it is constant for the materials. So, it is depending upon the material we use and it is measured in ohm meter. The resistance of some materials also changes with changes in their temperature. So, one of the another parameter upon which a resistance depends is their temperature. This principle of changes in the value of resistance with the temperature is primarily used for the measurement of temperature. So, there are some resistances which are temperature dependent and these type of resistances are used for the measurement of temperature. Some of the variable resistive transducers are sliding wire, which is also known as potentiometer, strain gauge, load cell, RTD, resistance temperature detector, RTD means resistive temperature detector, thermistor, hot wire anemometer, carbon microphone, humidity sensor. These are some of the examples of variable resistive type of transducers. Potentiometer, generally known as pot, is a 3-terminal resistor with one of the terminal is sliding, that gives an adjustable voltage divider. So, potentiometer is a 3-terminal device. Out of these 3 terminals, 2 are fixed and one is sliding contact, that gives an adjustable voltage divider. If only 2 terminals are used, that means one is fixed and another one is the wiper, that means sliding, it acts as a variable resistor or rheostat. Potentiometers are commonly used to control electrical devices such as volume controls on audio equipment. So, in audio equipments, to control the volume, we somewhat use potentiometers. Potentiometer is a displacement transducer. This is a passive transducer, that means it needs an external source to convert input into output. It consists of a resistive material whose resistance is proportional to its length. So, as length varies, its resistance varies. Slider displacement means displacement of the sliding contact is proportional to output voltage. But there are some problems also, as there is the common problem is dirt under the slider, as the dust under the slider, which sometimes gives error response. In case of potentiometer, one end of conductor is fixed. The position of other end is decided by the slider or wiper. This moving contact can move along the whole length of the conductor. When the body moves, the slider also moves along the conductor, so its effective length changes. So, as the input as the slider moves, the conductor there is a change in the effective length of the conductor. Due to the change of the length of the conductor, the resistance of the conductor also changes. The effective resistance value is measured between the fixed position of the conductor and the position of the slider. The resistance is calibrated against the input quantity, whose value can be measured directly. So, the new value of resistance that is between the fixed position of the conductor and the sliding position gives the effective resistance, and this resistance is calibrated against the input quantity which we want to measure. This is a circuit diagram of a potentiometer. VR is a supply, so it is a passive type of transducer. It needs an external supply. This is there are two contacts. One end is fixed, and this is a wiper. This is a sliding contact. With the change in its as this contact moves on this conductor, there is a change in the value of resistance, and this gives a variable output. This new adjustable this new output is calibrated against the input quantity. This is a potentiometer. The knob is used to move the slider. There are three contacts. Two are fixed. One is a sliding contact, variable contact, moving contact. There are some other diagrams of 3D diagrams of the potentiometers. In this case, there is a shaft. Shaft is used to move this wiper along the resistive element, so its resistance can vary. This is a again there is a shaft and there is a wiper. In this case, resistive material is in the circular form. So, with the change in the movement of the wiper, there is a change in the value of resistance, and this change in the value of resistance is calibrated against the input quantity. Another example of variable resistance type of transducer is thermistor. Thermistors are thermally sensitive resistors, generally composed of semiconductor materials. All resistors vary with the temperature, but thermistors are generally constructed of semiconductor materials with a resistivity that is especially sensitive to temperature. That means, some semiconductor materials having their resistivity depends upon temperature, and this resistance changes predictably with the temperature. With the temperature, there is change in the value of a resistance of device. There are two types of basic principles available in case of thermistors. One is PTC. PTC means positive temperature coefficient thermistors. Another one is NTC. NTC means negative temperature coefficient type of thermistors. In PTC, there is a increase in value of resistance with increasing temperature, whereas in case of NTC, negative temperature coefficient resistors, there is a decrease in the value of resistance with increasing temperature. The thermistor is an extremely non-linear device. So, there is no linear relation between input and output. The non-linearity is due to the high sensitivity. With the increasing sensitivity, sensitivity means how much output changes with the input. Sensitivity means output value changes with the input, but due to the high sensitivity, there is a loss of linearity. Thermistors are usually connected to an electronic circuit that reads out temperature digitally. Where we want to measure the temperature, there we use thermistors to read out temperature digitally. There is a relation between resistance and temperature, that is R is equal to R O exponential beta into 1 upon T minus 1 upon T O, where R is the resistance at temperature T ohm in ohms, R O is the resistance at temperature T O in ohms, beta is a constant, that is characteristics of material, and T and T O are absolute temperatures in Kelvin. Expression is R is equal to R O, where R and R O are the resistances at different temperatures, R at T and R O at T O. Exponential beta, beta is the constant depending upon the material, it is a characteristic of material, into 1 upon T, T is a temperature in Kelvin, minus 1 upon T O. NTC, that is negative temperature coefficient thermistors, operates over a range of minus 200 degrees centigrade to plus 1000 degrees centigrade. NTCs should be chosen when there is a continuous change of resistance is required over a wide temperature range. So, when we need a continuous change in the value of resistance over a wide temperature range, we prefer negative temperature coefficient type of thermistors. Negative temperature coefficient type of thermistors offer mechanical, thermal and electrical stability together with a high degree of sensitivity. Positive temperature coefficient thermistors are temperature dependent resistors manufactured from barium titanate and should be chosen when a drastic change in resistance is required. So, when there is a continuous change in resistance is required, we prefer NTCs, and when there is a drastic change in resistance is required, we prefer PTCs. This is a diagram of a thermistor. There are two terminals. So, the temperature due to the temperature its resistance varies. So, the wire is used to convert this resistance into we get electrical quantity in proportion to the temperature. Advantages of thermistors are inexpensive, their cost is very low, rugged, they are mechanically strong, reliable, respond quickly, highly sensitive, and they are manufactured in a wide range of shapes, sizes and values. Next example of variable resistance type of transducer is humidity measurement. Humidity means the amount of water vapor present in the air, and humidity measurement is the measurement of this amount of water vapors present in the air or gas. The humidity can be expressed in different ways, that is absolute humidity, or it is also known as relative humidity, or sometimes it is the word used as dew point. Devices that indirectly measure humidity by changing the by sensing the changes in physical or electrical properties in materials due to their moisture content are known as hygrometers. So, hygrometers are the devices which are used to indirectly measure the amount of water vapors present in the air due to because there are some changes in the physical or electrical properties of the material. The three major instruments used for measuring humidity in industry are electrohygrometer, the psychrometer and dew point meter. This is a digital humidity measuring device which gives temperature as well as humidity. This is 29.9 degrees centigrade indicates temperature, this 59% indicates the amount of water vapors present in the air at that particular time. A resistance hygrometer, this is an electrical hygrometer. It is an active transducer, so it does not require any external supply. These instruments are suitable for measuring moisture levels between 15% to 95%. It has typical measurement uncertainty of 3%. Atmospheric containments and operation in saturation conditions both causes their change in the characteristic drift. So, characteristics drift due to some other conditions such as atmospheric containments and operation in the saturation conditions. Some hygroscopic salts exhibit a change in resistivity with humidity. Resistive hygrometer humidity sensors use the change in resistance of a hygroscopic material between two electrodes on an insulating substrate. So, there is a change in the value of resistance between two electrodes, and that change of resistance is due to the humidity, and the material used is hygroscopic salt. The hygroscopic salt is deposited between two electrodes. The resistance of the element changes when it is exposed to variation in humidity. The resistance hygrometer should not be exposed to condition of 100% humidity, as the resulting condensation may damage the device. So, these type of devices are used from 15% to 95% of humidity. These are accurate to within plus minus 2.5% or in some cases up to plus minus 1.5%. Response times are typical of the order of few seconds. They take some seconds to give us a output. Humidity sensors can be used not only to measure the humidity in atmosphere, but also used to adjust some automatically control in humidifiers, dehumidifiers or in air conditioners for adjustment. Then another example is strain gauge pressure transducer. When the tension is applied to the electric conductor, its length increases, whereas its cross sectional area decreases. Due to change in length and area, its resistance changes. This change can be measured used this type of strain gauge type of pressure transducer used for measurement of force, strain and stress. A strain gauge is a passive type resistance pressure transducer whose electrical resistance changes when it is stretched or compressed. A pressure transducer contains a diaphragm which is deformed by the pressure, which can cause a strain gauge to stretch or compress. This deformation of the strain gauge causes the variation in length and cross sectional area, due to which there is a change in the value of a resistance. So, either it may be stretched or it may be compressed. There is a change in the length as well as the area of the conductor, due to which there is a change in resistance. The wire filament is attached to a structure under strain. So, the wire filament whose resistance changes is connected to a structure under strain, and the resistance in the strained wire is measured. The change in the value of resistance is measured. This is some circuit diagrams of strain gauge pressure transducers. They are used in a bridge type of configuration. So, there is one fixed points and there is a movable block due to the strain. When pressure exerts on the diaphragm, this movable block moves, due to which there is a change in the value of resistance. There is another example. This is a wire resistance strain gauge. This is a double bonded strain gauge. It has two strain gauges. Due to the pressure exerted, there is change in the there is a variation on this diaphragm, and there is a change in the value of resistance. This is another type of strain gauge pressure transducer. This is two wires. This when force exerted on this block, this flexible blocking, due to this there is a change in the value of resistance, because as we exert a force strain on this device, there is change in length as well as the cross sectional area of the resistance. Strain gauge pressure transducers are used for narrow pressure span and for differential pressure measurements. They are available